Okay, we're going to start conic sections now. Now, conic sections are four things. They're circles, parabolas, ellipses, and hyperbolas. If I had my model, I could show you why they're called conic sections. But basically, if you take a cone or a set of cones and slice through the cones at different angles, you get the four conics. We'll start with circles. We've done circles before, I think, in algebra. On each one of these, we're going to have a standard equation or a standard form. For circles, it looks like this. X minus h squared plus y minus k squared equals r squared. That'll tell you everything you need to know about the circle. The center is going to be hk, and notice these are both minuses, so you always take the opposite of what's in there. That's the center. So the center is hk. And then the other side, that's r squared. That's the radius squared. So whatever that number is over there, if you square root it, that's your radius. So if we have this equation right here, and if I ask you to say to find the center and radius and graph that, well, this is x plus 1, so that's like x minus a negative 1, so the center is negative 1, and then y minus 4, that's y minus k, so the center is negative 1, 4. The radius is the square root of 16, so the radius is 4. Now, if you're going to graph that, the kind of easy way to do it is, and we'll do this a lot on graphing, is find your center. So you'll start with a point there. Your center is negative 1, 4. Made that a little too big. So put that down. Now for the radius, if I go right 4, 1, 2, 3, 4, and left 4, and down 4, and up 4, there's my circle. A couple of other equations you might need on some later. Sometimes if they give you like the diameter of the circle and you need to find the center, well, the center is the midpoint. If you remember the midpoint formula, you average the two x's. So if they give you the endpoints of the diameter, you do that, and then you average the two y's. That'll give you the midpoint, which is the center of the circle. If you need the radius, we can use the distance formula. You find the distance from these 2 points, the 2 points on the circle. If it's a diameter of the circle, the distance formula, if you remember the distance formula, it comes from the Pythagorean theorem. It's the square root of, we subtract the x's, x2 minus x1 squared, and we subtract the y's. You may need that on some problems. If you're given the endpoints of the diameter, you can find the center by doing the midpoint formula, and you can find the radius by finding the diameter using the distance formula and then taking half of it. Now there's a lot of completing the square involved here in this section. I know everybody loves completing the square. We've done it before, but just to go over it again, here, a lot of times they'll give you the equation like this. Well, notice it's not in standard form. So we can't look at that and tell what the center and the radius are. So we need to put it in standard form. The first step is to group the x's and y's. So we have an x squared minus 6x, and I'm going to leave a gap, and then y squared plus 4y, and I'm going to leave a gap and move the constant to the other side. That's what we want to do first. So group the x's, group the y's, move the constant to the other side. Now to complete the square, I'm going to come down below here. X squared, this is going to be an x. Remember, to complete the square, we take half the middle coefficient. So half of a negative 6 is a negative 3. And write it down below that we're going to square that. Well, if I put a negative 3 and square it, that's a positive 9. So I need to add 9 to this to complete the square. And remember, whatever you do to the left side, you have to do to the right. So I'm going to add 9 to the right side also. Now do the same thing with the y's. Y squared is going to be y. Half of a positive 4 is a positive 2. Squared is a positive 4. So to complete the square, I need to add 4. If I add 4 on the left, I have to also add 4 on the right. So we have this on the left. On the right, we have 25. So we completed the square. Now, if you'll notice, we're in standard form. So this is x minus h. So for our center, h is 3. This is like y minus a negative 2. So that's a negative 2. There's our center. Our radius is the square root of 25, which is 5. Then again, if you're asked to graph that, we go to the center. So right 3, down 2. There's our center. Now if the radius is 5, we go right 5. We go left 5. We go up 5. And we go down 5. And if you were asked to label those points, you just look at them and say, okay, if I'm at 3, -2, and I go right 5, that puts us at 8, -2. Or you could count it on here. That looks like -2, -2. That looks like 3, 3. And that looks like 3, -7. And that would give us our circle. And that's how we'll do a lot of these. You'll draw your picture and you'll mark off spaces and then just look at your graph to find the points. So that's circles. Now parabolas, we've already done parabolas before. The ones we did were functions, so they were always vertical. So our equation for that looked like this. Notice the squared term is on over here, so it was x squared. The squared term is on one side. The term that's not squared is on the other side. That's what our equation looked like before. Now we're also going to have some that are not functions. They're horizontal. Well, that means the y is squared and the x is not. That's how you always tell a parabola. Only one of the variables is squared. The definition of a parabola, and you don't necessarily have to know this, but this is the definition of a parabola. It's the set of all the points in a plane that are equidistant from a point, which is called the focus, and a line, which is called the directrix. So if you were graphing that, like if we had a sideways one, if I had a graph, and let's say here's my directrix. So this is the directrix. And here was my focus. If I put all the points that are the same distance from this focal point as they are from this line, well, you'd have one point right in the middle between them. That's the vertex. Well, there might be another point out here somewhere where this distance equals this distance. Maybe there's a point over here somewhere where this distance equals this distance. Or maybe a point up here where this distance equals this distance. Well, if you put all those together, you get a parabola. That's a sideways parabola. So this is the directrix. This is the focal point. It's always in the middle. The axis of symmetry runs right here through the middle. Sometimes they'll talk about that. That's the axis of symmetry. This distance right in here between the vertex and the focus is called P. They use the letter P for some reason. It's also the distance here between the vertex and the directrix. That's also P. That's important. If you notice in the equation, there's a P in there. That's what P represents. The distance between those two. Sorry, I didn't get you to see that very good. Sorry about that. So again, here's the vertex. It's right in between the focus and the directrix. Maybe there's a point here where the distance to the focus equals the distance to the directrix. Here, the distance to the focus equals the distance to the directrix. Distance to the focus, distance to the directrix. If P is positive, it opens up if it's vertical. It opens right if it's horizontal. If P is negative, it opens down if it's vertical. It opens left if it's horizontal. So that kind of tells you where your parabola goes. So notice in the equation, here again we have H and K. That's our vertex. So our vertex is HK. We tell which way it opens by first seeing which variable is not squared. If y is not squared, it's vertical. It opens up or down. So if P is positive, it's up. Negative, it's down. If the x is not squared, it opens horizontal, left to right. So if P is positive, it opens right. P is negative, it opens left. So if we look at this equation here, I'll write this up here. I think this is on your sheet. If it's positive, it opens down if it's vertical, up if it's horizontal. Now here the equation is given to you in standard form, so everything we need is there. Here our vertex is HK, so H is 1. k, this would be like y minus a negative 2. Y is a negative 2, so that's our vertex. Here, this number here is always 4p. So we say 4p equals 12, so p equals 3. If we graph that, so we know our vertex is 1, negative 2. Here, x is not squared, so this opens left or right. P is positive, so this one opens right. So if this is our vertex, our focal point is always the direction it opens. So P is 3. If I go right 3, there's our focal point. So our focal point is at 4, negative 2. You can just read that off the graph. Our directrix is the opposite direction 3, so it's left 3, 1, 2, 3. So our directrix is right here. That's at x equals negative 2. And then we won't get too specific. We just kind of sketch our parabola in there, and there's our parabola. Okay. Here we're kind of doing the opposite. This one, they give us the vertex, they give us the directrix, and we need to find the equation. The first thing I would recommend is draw a picture of that. So if we do our graph here, our vertex is at 2, 3. Our directrix is y equals 5, so 1, 2, 3, 4, 5. So here's our directrix right here. Now if you look at this parabola is going to have to open down because it goes away from the directrix. Since it's up and down, this one is going to be y is not squared. So this is going to be this format here that's x minus h squared equals 4p times y minus k. We just need to fill in h, k, and p. Well, since our vertex is 2, 3, this out here is going to be x minus h is x minus 2. Y minus k is y minus 3. All we need is p. Well, here, the distance here from our vertex to our directrix is 2. Since it opens down, our p is a negative 2. So if we put that in here, 4 times a negative 2, so our equation is x minus 2 squared equals a negative 8 times y minus 3. I see I have that wrong on your note sheet. That should be a negative 8 instead of a positive 8. Sorry about that. All right. The last thing is if it's given to you when it's not worked out, we're going to have to complete the square again. So first step is over here, we're going to isolate the squared term. Well, if you notice this one, x is squared. So we're going to leave the x's here on the left side. So x squared minus 4x. Move everything else to the other side, so negative y minus 5. Now here we have a 2 in front of the x. We don't want that, so we're going to divide everything by 2. So x squared minus 2x equals, this will be a negative 1/2 y minus 5/2. So if there's a leading coefficient on that squared, we don't want to get rid of it, so we divided everything by 2. Now to complete the square, just like we did before, bring down the x. Here, half of the middle coefficient, half of a negative 2 is a negative 1. Squared is a positive 1, so we're going to add 1 to the left. When we do that, we also have to add 1 to the right. So now it looks like this. Negative 5/2 plus 1 is negative 5/2 plus 2/2 is a negative 3/2. Now, here we want to factor this negative 1/2 out of here. So if I divide by a negative 1/2, a negative 3/2 divided by a negative 1/2, well, 3 divided by 1 is 3, so that's going to be a positive 3. So our equation looks like that. So here's our vertex is going to be, there's x minus h. So our vertex is 1. Y minus k is y minus a negative 3. So our vertex is 1, negative 3. Remember, this number right here is 4p. This is going to be a weird one because it's going to be a fraction. 4p equals a negative 1/2. So p 1/2 divided by 4 is 1/8. So P is a negative 1/8. So if we graph that, our vertex is 1, negative 3. Since this is, the y is not squared, so this one's open up or down. P is negative, so this one opens down again. So we know it opens down. Now, our focus will be down 1/8. Well, if we go down 1/8, that means our y value goes down 1/8. So our focal point is going to be 1, negative 3 down 1/8 is a negative 3 1/8. Our vertex is up, our directrix is up from there, so it's up 1/8. So our directrix, if we go up 1/8 from a negative 3, our directrix is y equals, if we go up 1/8, that's negative 2 7/8. So this one's just really tight in there, but there's our parabola. So once you get it in standard form for your vertex, find out P, so go the direction the parabola opens to do the focus, go the opposite direction for the directrix. Remember, the directrix is always an equation, so it's always x equals or y dy equals. Parabolas are very useful. You see a lot of uses for a parabola. Because one of the things about a parabola, it's very useful. If I have a parabola and I put the focal point here, if light waves come in, like here's our axis of symmetry right through here. If light waves come in parallel to that axis, they always go out through the focal point. So if I have these light rays coming in parallel to the axis, they always come through the focal point, no matter where they're at. So you get something that looks like that. That's why these are used, like if you have a reflecting telescope, like the short, fat telescopes, they have a mirror in the back that's shaped like a parabola. So when light waves come in, like say from distant planets, it comes in and hits it, it puts them all through the focus. So that gives you an image that's big enough to see. Usually in those short, fat ones, they'll put a lens over here, and then there'll be a mirror here, a flat mirror. It'll reflect the light so you can see it. That's why a telescope is called a light gathering instrument, because it gathers light and focuses it so you can see it. You see the same thing. If you ever seen like on a football game on TV, they'll see a guy on the sidelines with a clear dish holding out there. What he's doing is he's pointing that at the action on the field, and he's picking up the sound from the field, like the pads hitting and stuff like that, or the quarterback singing signals, and it amplifies that because it focuses on one spot. That way, when you watch on TV, it sounds like you're close to the action. If you were actually at the game, it wouldn't sound that loud. You see the same thing. If any of you have like Direct TV or Dish TV and you have a satellite dish on your house, that's what it's doing. It's collecting those signals that come from satellites out in the atmosphere that are a long ways away. It collects them and focuses. If you notice, your dish has a thing right setting up in the middle of it. That's near where the focal point is, and it's focusing there so that you get a strong enough signal to see that. The opposite is also true. If you ever look in the back of a flashlight, behind the light bulb in the back of the flashlight, or in your car headlights, you'll see in your flashlight, like if it looks like this, the light bulb is right here. Well, if the light comes out of that light bulb, it goes out in all directions like it always does from a light bulb. Well, some of it goes this way and it's just scattered. But all the light that comes backwards and hits the surface comes out parallel. So all this light that goes backward comes out parallel. That's where you get the beam of light from your flashlight. It's weird, it's the light that comes out forward is the light you don't see. But it's all the light that goes backwards. If you ever open the top of your flashlight, you'll see a mirror in the back that's shaped like a parabola. That's what makes it go out. If you look in the back of your headlight, that's what it looks like in the back. So all the light that goes backward, comes out parallel. So that's some examples of parabolas: satellite dishes, radar, radio telescopes, reflecting telescopes, the back of a flashlight. All those are example of uses for a parabola. And that's it. Thank you.